Alright guys, we're going to finish the second part of your atmosphere notes. I'm going to start off with part 3, energy transfer in the atmosphere. Okay, so you should see this on your paper. Okay, sun transfers energy to Earth in one of 3 ways, and these ways should be pretty familiar to you from physical science. Okay, the first is radiation. Radiation is another word for light energy. Light energy means heat. The transfer of energy in the forms of electromagnetic waves. So examples of this are going to include sunlight. Okay, it could also be infrared light. Okay, which is another word for heat. Right, the things that we use. Okay, our body puts off radiation in the form of body heat. Infrared lights keep our food warm at fast food restaurants, that sort of thing. Okay, conduction is another way we transfer energy. This is a transfer of energy through collision of atoms and material. In other words, the items have to be touching in order to transfer energy. We see this happening in our atmosphere when we have a road like blacktop, making the air above it hot. You see that it looks like there's water on the road in front of you, but it turns out it's not. What you're really seeing is really hot air reflecting the sunlight, okay? Because the air above that hot surface gets very, very warm, okay? The Earth itself is warm, and it can actually transfer heat into the atmosphere as well. From the rock, from the molten area. So that's conduction. And then the last one is convection. This one's most important. We're going to spend some time on this later. Convection is the transfer of energy due to differences in density caused by temperature differences. What does that mean? In other words, guys, simple as this. Hot air rises. As air gets hot, it spreads out, becomes less dense, and therefore it goes above the cooler, denser air. Okay, we see this with hot air rising in our home. We also see it with cool breezes coming in off the ocean. Okay, we get those cool breezes because it pushes that warm air out. Okay, so coming off the ocean, and this is going to come into play. We're going to spend some time with this later as we go into climate, because this is a big thing about what determines what we have climates throughout our system. Okay, you have this nice example of the diagram on your paper that shows the different ways. So here you have radiation coming into the Earth. Okay, some of it's going to be blocked by the clouds, which is nice. We don't want all of it in there. Okay, we have some of it flowing around, getting warmer and hotter. This is your convection current there. We have it hitting the Earth and coming back off. So all these are different ways that Earth is warmed, and that's going to affect the atmosphere around us. Okay, the atmosphere itself, so we get warming of it. Solar energy again reaches it. It absorbs some of the light, but some of it is radiated back by Earth again, where it's hot, releases the energy. Okay, the rest of it could be absorbed or reflected by the atmosphere. So you have all those happening in the atmosphere at one time. Okay. How the atmosphere reacts to these changes in temperature is actually what causes both our weather and our climate. Now, they're not the same thing. Weather and climate are not the same thing. 2 different things. What's the difference? Well, let's start off with climate first. Climate is long-term prevailing weather conditions. Okay? At a particular location. In other words, guys, climate is something that some information we gather over a long time, usually about 30 years. That's what our usual definition is. Okay, so when we talk about climate, we're talking about things like average rainfall, average temperature, things that say, okay, this is what's going to happen. When we talk about biomes, they're based on climate. How much rain can you expect in a year? How warm will the temperatures get throughout the year? How cool do you expect them to get? That all has to do with climate. The weather is much shorter term. Okay, weather describes the behavior that we're actually seeing in our atmosphere over the day, over the weeks. Okay, you have your 7-day forecast. That's weather because it's short. Okay, the thing about weather is it can change instantly, or what seems like almost instantly, especially in Ohio sometimes. But climate, that's not going to change quickly. That comes over years and years and years. Weather changes almost instantly, climate does not. Weather is short term, climate's long term. Okay? Now, both of them are affected by the heat and the transfer of heat in our atmosphere. So when we talk about climate, when we talk about those things later this year, we're going to spend more time on how weather does that and what causes it. Right now, one of the big things we want to focus on is clouds, though. Okay? What is a cloud? Well, guys, I hate to say it, but as pretty as they are up in the air, clouds are really just fog that's not on the ground. Okay? So if you've seen fog, you've seen a cloud. And if you've been lucky enough to fly somewhere and you've been through the clouds, you know that although they look pretty from above, as the closer you get to them, the less form they have. Okay? Basically, what's happening with a cloud is you just have a whole bunch of water droplets that scatter sunlight. Okay? So they look like they have form because we're far enough away from them that they look like they have a shape. Okay? Water in our atmosphere can exist as a solid. You've seen it, liquid or gas. All of them are in there in the atmosphere. We get clouds when that water starts to condense on itself. Okay, it actually starts on something called a condensation nuclei or a cloud nuclei. Okay, that's where it starts. You have a picture here where one of those pieces of ash or dust that are in our atmosphere, the water starts to collect around it. Now that looks like a really pretty big piece of dust, but this is one of those things we've talked about with some of you. This is why you don't eat snow, because snow is actually pollution. Okay, it's dust. Like I said earlier, it could be dead skin. It could be bad chemicals for you. So you don't want to eat snow, okay, because that acts as a cloud nuclei. Now, if it's low enough in the atmosphere, if it's low enough in the atmosphere, it could be above freezing temperatures, and at that time the vapor just condenses to form water droplets. You see some pictures of them up here, okay? But actually, usually, because it is cooler, most of our rain actually starts out as ice pellets, like these first ones here. Then they'll melt and then refreeze as snow if it gets cold enough. But they all start out here. So if it's below freezing, they're going to be tiny ice crystals, either these columnar crystals, or it could be, and then melting and then starting the snowflakes, okay? So that's how we get clouds. Clouds have several jobs, okay? They are important for, obviously, creating precipitation. That's a big thing, okay? How do we get our water? How do we get rain? From precipitation. The other thing that it does, actually, it has to do with the same concept, is clouds, they move water from one part of the world to another. So they pick up the water in one area, and then they let it down in another. Okay? They also help protect us by blocking sunlight to keep temperatures cooler, or they can help absorb sunlight and make it warmer in some areas where we need it, so it'll act like a blanket depending on what's happening. And of course, it also can be used to help predict weather. Okay? We use clouds all the time for predicting what's happening, and you're going to learn that as you go through the NASA Globe certification later in this unit. Okay, so we're going to do a little bit more with that. If you have any questions right now, you're going to take a look. Go ahead, if you haven't done it already, look at your Cloud ID pages and your cloud cover pages. All right, if you have any questions, let us know. Have a good afternoon.